Hi, my name is Vincent, and today I want to show you all how to add and subtract rational expressions. So we have three examples here, and for each of them we want to add or subtract a rational expression, simplify it, and then say for which value of the variables will the fractions be undefined. So if we look at this first example here, the strategy we want to use for all of these questions is we want to find common denominators. So if you compare 2 minus x with x minus 2, these are almost equal. But all I have to do is just multiply 2 minus x by negative 1, and it's going to equal x minus 2. You can see if I distribute negative 1, I'm going to get exactly this. So that tells us when we're trying to do the first question, this is like one of the simpler cases, is we just need to take the first fraction and multiply the top and bottom by negative 1. So we're going to do that for the next step. And then when we work this out, for the first fraction, negative 1 times 1 is negative 1, and then for the bottom, make sure you distribute, or just remember what we said before, negative 1 times 2 minus x is equal to x minus 2. And then the rest of this, we got plus 2 over x minus 2. So now we've accomplished what we needed to. We have matching denominators, so we can write this as a single fraction, and all we have to do is just add the numerators together. So we have negative 1 plus 2. So the first one works out to just 1 over x minus 2. Let's just make that a little neater. So 1 over x minus 2. All right, but the rest of the question says determine for which values of the variables the fractions are undefined. So for both of these, if you look here, 2 minus x and x minus 2, the denominators will be 0 for both of these if x is equal to 2. So that's the only forbidden value here, is that x is not allowed to equal 2 for the first question. So this is our solution to the first problem. Now for the second question here, there's a lot going on, but my advice for doing these, strategy-wise, you want to look for a least common denominator between both of those fractions. So the strategy we want to use is we're going to factor both of these denominators. Now for the first fraction, we're going to have 1 over, and this is like a somewhat simple one to factor. We're looking for two numbers that have a sum of negative 1. That's the coefficient here. So a sum of negative 1 and a product of negative 6. So if it's multiplying to a negative, that means the first number could be positive, the second could be negative. And then here the two numbers are going to be positive 2 and negative 3, because 2 minus 3 is negative 1, and 2 times negative 3 is negative 6. And then we just put the variable y in front, and that's how we factor the first one. Now for the second one, for this I'm going to go on a side quest, and I'll kind of just take you through my thought process for what I'm doing. And what we're doing here is I'm looking at the AC term. And what I mean by the AC term is the product of the first coefficient and the last. So I'm doing 2 times 3 is 6. And then the B term, or the middle term, the coefficient of y here, is negative 7. So I'm trying to come up with two numbers that have a product of 6 and a sum of negative 7. And the two numbers are going to be negative 6 and negative 1. Now what those two numbers represent in this context here is it tells you how to break up the middle term. So I'm going to just take 2y squared, and I'm going to split negative 7y as negative 6y minus 1y, and then just write the plus 3 at the end. And the reason we do this is so that we could do factoring by grouping. So we're going to just break this into two separate groups. So the GCF of the first part is 2y, and we have a leftover of y minus 3. And then the goal is to create a matching factor of y minus 3. So here we could take out a negative 1, and we're left with y minus 3. Because if we distribute that negative 1, it brings us right back to negative y plus 3. So then the factored form is y minus 3 times 2y minus 1. And we could write our second fraction in that form here. So we have 1 over y minus 3 times 2y minus 1. All right, so assuming you have all this copied or you followed all of this, I'm just going to get rid of this now. So the whole point of that was just to be able to factor the second fraction. But now once it's all factored, that helps us identify the least common denominator. So you just have to write all the factors that appear you just have to write them as they appear. So we have the factor y plus 2. We have the factor y minus 3 showing up in both of them, but you're only going to write it once. And then we have the factor 2y minus 1. The only time we would write y minus 3 twice would be if for one of them it was squared. Then we would have to put a square up here. But if it shows up in each of them exactly once, you only write it once. So then what we need to do in order to be able to simplify this is we need to multiply each fraction by the missing factor. So you see how here we have y plus 2 and y minus 3, but 2y minus 1 is missing. So for the first fraction, we're just going to write in 2y minus 1 on bottom, and we're going to write the same thing on top. So we got 2y minus 1 on top. Now for the second fraction, the missing factor is y plus 2. So we're going to write a y plus 2 on bottom, and then we're going to write the same thing on top. So we're going to be multiplying them by different things, but it's based on what's missing. Now once we do this, now we have two fractions that have the same denominator. So we could just turn this into a jumbo fraction, like one big fraction here. Let's just make that a little bit nicer. All right, so there we go. So we're going to have, and I'll write this in a separate color. We've got 2y minus 1 on bottom times y plus 2 times y minus 3. Okay, and on top, we have the first numerator is 2y minus 1 times 1, which is 2y minus 1. And then pay attention to this part. This is where most people go wrong from what I've seen, like, from students over the years. You're doing minus 1 times y plus 2. Please make sure you write the second thing in parentheses because you have to, later on in the next step, you have to distribute this. So just be careful because a lot of people forget to do that distribution step and it throws off the whole question. All right, now I'm just doing that to be lazy because I don't feel like rewriting the whole thing because it gets kind of tiring. But when we go to the next line, we have 2y minus 1, and then we have minus y minus 2. So once this simplifies, and I'll just do this again, and I'll just resize this here so you can all see it. All right, so for the next and almost final step, we have 2y minus y is y, and then negative 1 minus 2 is minus 3. So at this step, notice, and I'll write an invisible 1 next to this because this factor is going to cancel. The y minus 3's go away. So the final step here, we'll write the simplified version. We can write this as 1 over, and we have 2y minus 1 times y plus 2. Okay, so this is the final form here, and it's factored. If you wanted to, you could multiply these two together, I guess, at the end, but this is a simplified version of the original expression. Now, the one thing we also have to do here is say for which values of y is our rational expression undefined. So the y values come from the original. Do not say like, oh, y equals 3 is okay because this canceled out. That would be a big mistake. So you're finding the roots of each of the factors from the original expression. So the factors here, y plus 2 will give you a root of negative 2. And that would make the original expression undefined. So we have to include that in our list of y values that we can't use. Now the the last factor here, if you solve for y, you're going to get y equals 1/2. And then this middle factor is going to give you y equals 3. So basically y is not allowed to equal any of these values here for our final result. This concept is important later on when you start talking about piecewise functions, so that's why it's included in the question. But this is our simplified version of question 2. Now for the third question, we have 3 fractions involved here. So same idea, we want to find a least common denominator. And the better you are at factoring, the easier these questions are. Like looking at y squared minus 2w, when I look at that, I immediately want to say that's w times w minus 2. And you'll notice the only factors involved in this question are w, w minus 2, and w squared minus 2w. So in a situation like this, this last fraction can be left alone because it's made up of the only other 2 factors that show up. So you don't have to multiply this by anything because it's already done. So then what we're going to do, we got 1 over w, and that's missing a factor of w minus 2. So this first one, we could say we're going to multiply by w minus 2 over w minus 2. Now the second piece, the 1 over w minus 2, that's missing a factor of w. So we would multiply the second fraction by w over w. And then, once again, the last fraction, the minus 2 over w squared minus 2w, can be left alone because the denominator is made up of the factors w and w minus 2. So this is all the same. So what we could do now, because these three fractions all have the same denominator, is we can combine them into a single fraction. So we have 1 times w minus 2 is w minus 2. Then we have plus 1 times w is w. And then we have minus, and there's no trap here with distributing a negative because it's only one term. So we have minus 2. And then on bottom, we have w times w minus 2. I'm writing it in factored form because later on a factor will cancel. But if you wrote it as w squared minus 2w, that's not wrong, but you would have to factor it later. So then the next line, we have w plus w is 2w. And then negative 2 minus 2 is negative 4. And we're over w times w minus 2. Now, if you stopped here, that would be sad because we can do a bit more. If we factor out a 2 on top, we have 2 times w minus 2 over w times w minus 2. And then in this case here, these factors will cancel out. And the remaining expression here is just 2 over w. But now remember, when we include the values for which the variables are making these fractions undefined, we have to go with the original. Like if you were to only say, oh, w is just not allowed to equal 0, and you stopped here, that would be bad because we have to also consider in the beginning that if w were to equal 2, this middle fraction here would be undefined. So we have to include 0 and 2 in this mix. We don't have to worry about the third fraction because when w equals 0 or 2, it makes the last one undefined, but it does it for the other two fractions as well, so we don't write it twice. So these are the forbidden values for the third example. Okay, well, this is going to conclude this video on adding and subtracting rational expressions. If you found this video helpful, please click like and subscribe below. And if you have any requests, please leave them in the comment section below. Thank you for watching.